This lesson is 4.2. We're going to multiply and divide rational expressions, and we're going to simplify as we go, okay, or simplify when we're done. So again, you have multiplied fractions probably since what? When do you think you learned multiplying fractions? Really? Second grade? Did you multiply fractions in second grade?
Oh, multiply fractions?
Multiply fractions. Third or fourth?
Yeah.
Okay, so you've done this for a while. So you know that if you take, say, 2/3 and you multiplied it by 4/5, how did you do that? What's the rules? Just straight across, right? You multiplied 2 times 4. You multiplied the numerator and you multiplied the denominator. Not the way we add or subtract, right? It's harder, actually more difficult to add and subtract. But we're just going to be multiplying today. Okay. If you had something like 2/3 times 9/10, now I'm going to put the little decimal here, not the decimal, but the point for multiplication. Because when we start throwing in the letter x, we don't usually use this symbol because it could be confusing. Okay, so we'll put that for multiplication. You could multiply, you could go 2 times 9 and you could go 3 times 10. Okay, and get 18 over 30 and then try to find common factors from there. But there actually is a better method. As long as this is all multiplied, it's really like, and I wouldn't necessarily want you to write this way, but this is what it is like, what we just were doing. And then you would look from here, any common factors in the top and in the bottom, and attempt to reduce those. Because it's all multiplied, I can do that, right? So I could cancel this 2 with this 10, leaving a 5. I could cancel this 3 with this 9, leaving a 3, and I'd have an answer at 3/5, which is the same as if I multiplied out and got 18 over 30. And since you guys have done this for so long, taking 18 over 30 and reducing that to 3/5, not a big deal. But when you start getting bigger and bigger and bigger with variables in there, it's going to be easier if you will just reduce here. And now, again, this multiplication and this multiplication are the same. So right here, if you're multiplying, if up here and you have a 2, down here you have a 10, we're just going to reduce. Anything in the denominator, anything in the numerator that share a factor, we're going to cancel those. Okay, and we're going to do it just like we did when it was all just a single expression. Okay? So, for example, well, actually, let me show you couple others of these before we throw the variables in. If I had 5/12 times 4/10, now I'd like to just start reducing where I can. All right? I can reduce the 5 with the 10, right? I take a 5 out of both. What would be left under this 10? 2. And then you have a choice. You can reduce the 4 with the 2. I'd probably honestly reduce it with the 12 because I could reduce the whole thing, leaving a 3 here, but what's left on top when I reduce those? Really ones in both cases. And so you'd have 1 times 1, you'd have 1/6. I feel like that's easier than taking 20 divided by 120 and reducing that. That's not so bad either, 20 over 120, but that's so simple. You got the answer right there, 1/6. Okay, same rules apply as far as if you had 3 plus 2 over 5 plus 2. Can I reduce those 2's? No. Okay. But as I showed you before, if I had 4 times 3 plus 2 over 5 times 3 plus 2, that's where I could reduce those. And this is more what our problems are going to look like, because there's going to be variables there in place of the 3. Okay, so you'd reduce this and get 4/5. So similar, very, very similar to the previous set of notes. Okay. All right, now let's throw in letters. And it's going to involve factoring again, so that's why we practice so much factoring. The directions are going to be to find the product. At this point, we're not going to worry about excluded values anymore. It just gets so complicated. You're doing all this factoring, we won't worry about excluding them. So only on the basic simplifying are we going to do the whole excluded values. Okay? All right, so number 1, here we go. 3x squared over x plus 2 times x squared plus 3x plus 2 over x. Okay, so any common factors that are up in the numerator and down in the denominator, I'm going to be able to reduce. I see right off that I could cancel an x right off the bat. This x here with this x, this one, I can reduce. Not these. These are tied together with that plus sign. I can't do those. But I could reduce this x with this one leaving just x. Well, actually 3x. I'm going to leave it like that. Then here I'm going to attempt to factor this. So I'm going to rewrite what I've got here. I got a 3x over x plus 2. And I'm going to factor this, which now has just 1 in the denominator. What does x squared plus 3x plus 2 factor into? X plus 2, x plus 1. Okay. Do you see where we could cancel an entire factor here? X plus 2's, right? Looks like our denominator is going to completely cancel away. And leaving up in the numerator 3x times the quantity x plus 1 all over 1. That answer is beautiful. I would leave it like that. Okay? If this was multiple choice, maybe they would distribute in the 3x, but you don't have to. Factored or not, neither is considered simplified. So why risk making a multiplying error? Just leave it like that. Okay? All right, let's try another one. Number 2, x squared plus 5x plus 6 over x squared plus 3x plus 2 times x squared plus 7x plus 6 over x squared minus x minus 12. Can I cancel all those x squareds? No, thank you. Can't do that. Can't cancel anything right now unless it was the exact. If I had an x squared plus 7x plus 6 down here, I could cancel, but I'd have to have all three terms. Okay, so we're going to factor it all. All right, we ready? Alina, I want you to help me factor. What would x squared plus 5x plus 6? I'm going to put that right here. What would that factor into? X squared plus 5x plus 6. 2 and 3. Both positive, right? So x plus 2, x plus 3 is what that top factors into. Okay, now let's factor the bottom. Caleb, can you help me factor that? X squared plus 3x plus 2. 1 and 2. Both positive, right? Plus 1 plus 2. Okay. Then we're going to go to this one. X squared plus 7x plus 6. Melanie, can you factor that one?
X plus 6, x plus 1.
Okay. And then maybe the trickiest one here, just because it involves some negatives. X squared minus x minus 12. You got it? Celeste, what would it be? X minus 4, x plus 3. All right, and then this is kind of a fun part. Anything that's common in the numerator and in the denominator you can reduce. Okay, so I'm seeing an x plus 2 here and here that I can reduce. I can reduce an x plus 3. And one more thing. X plus 1s, all those are going to go away. So what's left? X plus 6 over x minus 4. Okay? Scale 1 to 4. 1, I'm really good with this. 4, I'm really not. Tell me where you're at, please. You good? Where are you at here? Back here, guys. Okay, good. Awesome. Then we're going to go to division. Honestly, division just adds one little step. That's it. Otherwise, it's pretty much the same thing. Okay, so if I was going to divide now. It's the same rules as you do when you divide fractions. Exact same rules. So how do you divide, say, 1/2 divided by 2/3? What do you do? Keep it. Switch this and flip it. I like it. Keep it, switch it, flip it. Okay. So, or you multiply by the reciprocal would be the formal way of saying that. So multiply and then flip the second one, right? Whatever you're dividing by, 1/2 divided by 2/3, you'd flip it over. And then multiply straight across, reduce if you can. Nothing reduces here. There were no common factors, so 3/4 would be the answer. Okay. Also, if you had it, this exact same problem could be written this way. 1/2 divided by 2/3. If you had something that simple, I would do this the same way, okay? Flip the denominator over. I like to show it like this. You flip this, okay? Flip it over and multiply. So it'd be 1/2 times 3/2. Flip it over. Same answer. So again, these two mean to do the same thing. So flip the second. Flip what you're dividing by, or what's down in the denominator, that's what you multiply by the reciprocal of. Okay, so directions are going to be to divide these rational expressions. All right, x squared minus 25 over 4x plus 28 divided by x minus 5 over x squared plus 9x plus 14. Okay, so which part are we going to flip over? The second one, right? This we're going to flip over. Okay, so I'm going to rewrite this. Let's leave a little space. Let's just factor above these, okay, so we don't use so much paper here. So I'm going to flip this over and multiply. And then let's factor up above.
You always flip over the second one?
Yes, it's always the second one you flip over. Multiply by the reciprocal of the second. Okay, so can we factor this on top? X squared minus 25. Factors, right? Katie, what's that factor into?
X minus 5x.
Okay, difference of two squares. I'm going to write it above here. And then underneath here, Alexia, how would you factor 4x plus 28? GCF. What's the greatest common factor?
Oh, cool.
Yeah, just pull out a 4, what's left? Okay. Then we need to factor this one. That's a trinomial, so it's going to factor this way. Nick D, can you factor that? X squared plus 9x plus 14? Okay. And then x minus 5 we can't factor at all, right? All right, looking for common factors here. I see an x minus 5 that I can cancel. I see an x plus 7 that I can cancel. Whoops, I did this wrong, didn't I? It's supposed to be x plus 5, x minus 5, right? And that's it. Can't reduce anything else, so I'm going to leave this answer as x plus 5 times the quantity of x plus 2 all over 4. Is that right? We good? Okay, let's try another one of these. 4k plus 8 over 6k minus 10 divided by k squared plus 6k plus 8 over 9k minus 15. Okay, so which one do we flip over? The second one, right? So keep the first one just like it is. Leave a little space above so we can factor above it. So 4k plus 8 over 6k plus 10 stays the same. Change the sign, and I mean not change the sign, but change it to multiplication. And then flip it over. Okay, and then it's all about factoring here. Eros, how would you factor 4k plus 8? Okay, what would be left? K plus 2. Maddie, how would you factor 6k minus 10?
Take out a 2.
What would be left?
K minus 5.
I think there's a little bit more. You had a 6 here, right? If you pull out a 2, there'd be 6 divided by 2?
3K.
3k, yeah. 3k minus 5, right? Adrian, how would you factor 9k minus 15?
Go out of 3.
What would be left?
3k minus 5.
Okay. All right, and then this one down here, honestly, I'd be looking for some of these factors. I don't think we're going to get 3k minus 5, but I'd be looking for a k plus 2. That would just be my instinct. All right, so we got a k and a k, 2 factors of 8 that add up to 6. 4 and 2, right? There it is. So we did get the k plus 2. All right, let's reduce. I'm seeing a 3k minus 5 we can reduce. I'm seeing a k plus 2 we can reduce. But then we also can cancel what else? The 4 and the 2, right? So this is going to leave a 2. Okay, so let's see what we got left. All of this reduced except for 2 times 3. So actually we'd end up with 6 on the top, right? And on the bottom, everything canceled away except for k plus 4. That's pretty. Okay, and then let's just do a couple with the other notation, and then we're done. Can I turn the page?
Yeah.
We good? All right, number 3. 1 over x minus 2 over x plus 3 over x squared minus 4. Okay, so just written a different way, but it's the exact same thing. So which one do you flip over? the denominator, right? This is the one I like to flip him over. Okay, so the 1 over x minus 2 stays. Change it to multiplication and put the x squared minus 4 on top, the x plus 3 down in the bottom. So these two that are closest together right here, they end up down in the denominator together. This guy that was way on the denominator, he ends up on top. Are we going to be able to reduce anything? Not right now. Can we factor this at all? Savvy, how would you factor it?
X minus 2x plus 2.
The top here, right? X minus 2x plus 2. So I'm rewriting that as x minus 2x plus 2, and I can reduce. This is, again, like it's in parentheses, right? These guys are all tied together. So I can cancel him, but not the x plus 2, and there was a 1 here. So 1 times x plus 2. This becomes 1 times x plus 3. Can I cancel those x's? No, you cannot. They are tied together with a 2 and a 3 by that plus sign. You have to cancel the whole thing. All right, last one. 2x squared plus 5x minus 3 over x squared plus 4x plus 3 over 2x squared plus 7x minus 4 over x squared plus 2x minus 8. Okay, so again, this is a fraction divided by a fraction. We flip which one? The denominator. Take him, flip him over, and multiply. Okay, so I'm going to rewrite it down here. So the 2x squared plus 5x minus 3 over x squared plus 4x plus 3 will stay the same way. And change it to multiplication, and then flip this guy over. So x squared plus 2x minus 8 goes on top. And 2x squared plus 7x minus 4 goes on the bottom. All right, factoring this is going to be a little trickier because of those leading coefficients, huh? That always makes it a little bit more difficult. So let's factor the top, reasoning this, okay? Kind of trial and error. The only way to get 2x squared is 2x and x, right? This has to be 2x and x, and then really we only have 1 and 3. We just got to figure out where it goes, so I'm going to write this in pencil so that I could erase. If I put the 1 here and the 3 here, then doing the little smiley faces, which I'm going to have to do upside down here, this would be 1x, this would be 6x. Any way to get that to be a positive 5x? Yeah, so which one would I want to be positive? Do I want the 1 to be positive? No, I think I want the 1 to be negative, right? And then the 3 to be positive, because that would cause us to have a positive 6x and a minus 1x, right? Okay, down below here, this one's a little easier, because these are just x and x. 2 factors of 3 that add up to 4. Vini, what would it be? Can you factor this?
No, I can't.
2 numbers that multiply to be 3 that add to be 4.
Oh, 3 and 1.
Yeah.
Yeah.
Yeah, it's okay. And it's all addition. It's okay.
I was in for that.
All right, then let's come up here. Set this up. Again, these have to be x and x. Okay? 2 factors of negative 8 that add to be positive 4. Abby, what would that be? Abby, S. 4 and negative 2. So positive 4 and negative 2. Do you guys agree? Positive 4x and negative 2x. Yeah. All right, and then the last one, the tricky one. Again, this has to be 2x and x. That's the only way to get it. For 4, we could have 1 and 4. We could have 2 and 2. You want to do 1 and 4? In that order, 1 here, 4 here? Okay, this would be 1x. This would be 8x. Can I make that be 7x? Minus 1 plus 4. That would do it. Plus, I'd kind of look for common factors here. All right, now let's see what can reduce. 2x minus 1s. It's kind of like a puzzle, huh? What else? X plus 3s can reduce. X plus 4s can reduce. Anything else? Nope. That's it. So on top, all we have left is x minus 2. On the bottom, all we have left is x plus 1. Can I reduce those x's? No. They're tied together. All right, 1 to 4. Where are you at with this? Totally have it 1. Totally don't. 4.